ball, like I could have the ball, if it gets in here, it could actually block the laser. I mean, not to overcomplicate things. I'm just saying.
You are seriously. You're
Are you
serious.
saying I'm worse than my student?
Yeah, like his ideas are same. You.
So this is what the student's conversation I had. He's really into this pathfinding idea. I don't think it's a pathfinding idea, but basically what he wants is he wants a NPC entity, for lack of a better word, to follow a player. That's what I'm hearing from him. He wants an NPC character to follow a player. Happening. I think, because I've done what you're saying before by accident. You're not accounting for the fact that we do not have kinematic bodies. We have physics bodies as the player.
Doesn't matter. They'll just walk and get stuck until you move. So the point
moving platform, though. Think about it. You have a timing. You have the one character jumps. You wait for the other character.
So
yeah. I don't know.
We can make the character a kinematic, and he can just fly over.
Now you got it. I said that. Let's do a kinematic ghost.
Okay.
What? No collision. It will actually just find the last player position and move to the player's position. To be honest, speaking of this, if it's not really an NPC or whatever the hell this thing is, it's just like a graphical thing, right? Kind of like, did you ever play Zelda?
No.
Well, it's this idea that there's like this floating fairy near you all the time.
Yeah.
I think that's what he's trying to create here. Isn't it easy just to have it find the player position?
Yes, like it's rather easy and just move towards it. And then if the distance is less than half a meter or whatever, stop. So stop trying to move towards the player. So we can do it in like 2-3 lines.
Okay. Let me do this setup then. Hold on. Let me do this setup then really quick. Let me go make something in 3D. Okay. All right. And then let's what do you call it? So let's just go for. I say we just go for a floating fairy.
Yeah. I would go for that. That sounds like
facial. Let me change this really quick. Change type to good old Kitty.
What do you want to do? I want to do Feathers.js. Yes.
Pause right here. I need to have I think collision shape. I believe a collision shape is needed. Okay, collision. All right, collision shape, and then we get we have a collision shape, and what else do we have? Use that shape in there. Blink. All right. And then we will go with, let me set this up. I'll do it right. Let me go get a sphere. Because you know what we could do also for, if we do make this a video, I could say, hey, how to make a Zelda fairy. Get some of that Nintendo nostalgia.
You can't call it Zelda. It has to be Çalda fairy or whatever.
Yeah, I know. And we'll put like a fake elf. I can render a good elf, I think. Or find a decent elf thing. Okay, all right. So, and let's get a CG sphere. And then what we'll do here is we'll create an animation here, an animation player. And then what I'll do is I'll put the animation player up here. I'll then put a material on here. Okay, wait, where is the CG sphere? Get a material on here. Empty, new spatial material. Flags. Unshaded, fine. Let's do a Godot color. Change this to be like that will do. All right, okay. And then actually what we can do is great, is that you can animate everything. You can even animate the shader. That's why I love this thing so much. Okay.
All right, click this right here. We're gonna go yes. Click, make a key, create. Right over here, we're gonna change this one. We'll click it again. We'll change the color to something a little darker. We'll press OK. Yes, too dark. There we go. All right, click away and then click. It could be a little darker and then unshaded on. Yeah, unshaded on. Okay. I barely noticed that though.
What is it?
Click. Okay. Now play. Okay, we'll have it flash a little bit.
So take this one right here. We'll duplicate this key. Over here, duplicate. Great. Now we have it a little flash. There we go. Now it's got a little blink on it, like it's a talking orb. Okay, save the scene. Cancel, save. Okay, all right. Okay, I got it. And then let's name it Sprite, ironically. You can ask me for a key if it's easier for you to program it, or you can take me through it. How do you want to do it?
Well, this is small enough that let's risk trying to program it by you. Okay, so let's think about the problem, right? So the first thing is, how do we want to move? Can you explain to me how will we move to the player? Will we
Yeah, hold on. Let me save this really quick.
What will we do?
We're gonna call it where do I even put this thing? I don't have a thing for characters. Platform resource. I guess we'll put new folder NPCs. All right. Sprite scene, great. Okay. Well, like I was telling him, I think the best way, let's let me get this in here, is just to simply have it find the player. I'm just about, that's all I'd rather do. Like, I'd just rather have it find the player. So like, you know, it just, I think wherever, so I think without the, we could add a wait timer. We could add a wait timer.
No.
Oh, okay, no wait timer. It just should go where the player's position is.
Exactly. Okay, how will we do that in code? How do you think that can be done?
Well, we're gonna need the three. We are gonna need to update where the three positions are.
Player position. This is the ghost position. And how will we go? Will we teleport immediately to here?
Well, not teleport. I think we should
teleport immediately to there first. Let's do that first. So
okay.
Let's teleport immediately to player position. So how shall you do that? Just, I mean, okay, you need a function first. Which one shall it be?
Function ready. I don't.
Okay, let's use function ready. Okay, great. So so literally what we need to do is self dot. Yeah, self dot, is it position? No, spatial, what is it? Transform. Self dot transform equals
Player position? Or the player?
Equals,
hold on, what's the player?
Player dot transform. So you need to go
right here?
out and player physics. Yeah, so you need to go minus slash player physics. Oh, actually, no, let's not complicate. No, let's not complicate.
Should it equal itself?
Okay, so it's not the equality sign, it's the assignment operator, so delete one of those. Okay, good. Now wait, this is so small I don't actually see what's happening. Okay, well now you need to ensure that, okay, that's not gonna work because that's not the correct path, because you know where here do you see player physics. You need to go.
Got it.
Okay, that thing needs to be after the lower side. Okay, and it's not going to be 2 slashes, just 1. And close the. Okay, great. So yeah, you close the dot. So we're just going to copy the transform of the player. So you just type in transform. Okay, do you understand what we're doing here?
Yeah, it's just making the thing move to where the player was. I mean, I
everything. We're copying both the position and rotation. Okay.
Okay. Should I test this?
Yeah, let's test that. Save it.
Okay.
Save it first. Save it first.
Got it.
Okay. Now test it. And I guess we'll able. Is it here somewhere? Where is the ball?
Yeah, I moved it down. It's there.
Okay, great. So let's do it.
Whoa.
Wow.
How did I fall through here?
Hey,
Why did I
hey,
fall
well,
through?
I don't know.
It's weird. Oh, maybe because we copied it directly.
Well, that should
Oh, look,
make
I'm flying now.
that should make a copy. Maybe you are
I'm-
bouncing off of our character or something. When okay, try commenting our line. Let's see if our line is causing this. If not, then you're gonna have to debug this for me.
All right. Again, there's other things I want him to work on, but his curiosity should be rewarded, I suppose. Oh, wait, I should put pass. Oh, this is not gonna run. Yeah. Tab.
Okie dokie. So what are we doing?
Oh, I have to hold on. I have to run it again because I forgot to put the pass after I commented out the function.
Yeah. Okay. Great. Okay, do that.
Okay, here we go. All right, yeah, it's our code.
Well, try it again. Let's see. Okay, let's see what about our code. So I don't know what could cause this.
You know what? Control K.
I mean, try self-transform.position, I think, equals
Self-transform dot position.
Yeah, something like that. Not position. Go check what transform has. Shift 1, sorry. Shift F1. Shift F1. Let's see what transform contains. Basis origin. Basis origin, I think. Something like that. Transform. Type in transform. So no, type in transform. Go to find the class. What is the transform? No. No.
Not get transform. Oh, sorry. I put classes. Classes only.
So transform is not correctly spelled.
You never transformed before? Come on.
Okay, so open that one. Let's see what the transform contains. Basis. Yeah, okay, origin. Sorry. So origin is the location and basis is some whatever. So no. Just type in origin instead of transform.origin equals flare physics transform.origin. And this should global transform.origin.
Got it.
No. Global transform is with an underscore.
Oh, the whole thing. Okay. That's what I thought you meant. It was two transforms. Okay, there we go.
So this is just a really nasty way in Godot to figure out where the position of the spatial is. So, okay, well, what is the game? Why no game?
What do you mean?
Okay, find the.
Ball's still there.
Well, okay, let's. Did it error out? Can you check?
What, do you think it went backwards? Oopsie.
I'm really not sure why it's. I'm really not sure why it's not working. So okay, let's. Oh, because maybe this was never set. Okay, so I'm not sure why it's not working. Go inside. No. I mean, go here. Okay, so.
Do you have a collision shape on it or no?
No, it doesn't matter. The collision shape doesn't matter. So.
Well, I've got a question. Can we just have it be the CSG sphere and get rid of the sprite?
It doesn't really matter.
Okay.
It should all be there, basically. Oh, maybe you're right. Maybe the sphere isn't moving because animation player doesn't have. Can you move CSG sphere directly into the sprite?
Oh, like the sprite is moving?
I don't know. Maybe that's the problem. Try
That,
it now.
oh, I see what you're saying. Yeah, that could be. Okay.
What is the game?
Yep, you got it.
Okay, so you have a problem now. Can you tell me what the problem is in your words?
It's not checking all the time. It's only
Okay,
checking upon
how
ready.
do you think, what runs all the time? What function? You need a function to write that code in. What function writes all the time?
Hold on. Function process.
Yeah.
Function space process. Process delta.
So we are at 2 a.m., right? At your time.
Yeah, 2 a.m. Okay. Thanks for keeping an eye on that.
Okay,
Function
so yeah, so what now? You're the programmer, you tell me.
I want to check it. I just don't know how to check.
No, I want you first to just constantly update it. So just copy the code below for now.
Well, so I need to attach it to frame. Every frame? Is that even
Yeah,
a thing?
no. What are you doing? Don't touch it. Try it like that. Let's program.
Oh, I see, because it should automatically be doing it. I got it.
Program it one part at a time until you get good enough to do all of that in one go, like I do.
And we have the delta already. So
delta is easy to catch. You just type in.
Oh, yay! Great. It's literally on us. It's literally on me. Ooh, I turned on the laser. Hey, you know what? This is getting prettier.
Anyways, so.
All right, okay. We just need to offset it now.
Okay, so this is like a vector, and this is like a vector. So if you minus one over the other, you'll get their difference. So what I'm trying to say is,
but from the player, huh?
Yeah, but I don't want to do that. You know.
Yeah, that's kind of cheap. That's very limited. Okay.
Okay, wait. So now I want to move both of these. So let's create a var a equals one of these. No. Here. In the
inside. Okay.
Yeah. Okay. Var a equals this one. Just copy it.
The whole line. I got it.
Not the whole line. The part that's. Okay, and var b is the remaining part.
Got it.
Okay, so now. So this is A and this is B. If we do B minus A, that will give us the dot here, okay? Because it will minus this part. If we did B plus A, it would give us this thing here, okay? So let's find the distance by minusing the two vectors. So var distance equals B minus A. Okay, and let's remove this here, this dot, and print in the next line the distance so that we have an idea how big it is. And then comment line 11. Okay, so print distance there. Okay, great. So save it and test it. So let's see what distance it's outputting. So was that vector math hard?
No.
Okay, well, let's see the distance. Is it changing in the correct direction or something?
Yeah, it is.
Okay, so seems to be working. So kill it. I mean, you know. Okay, so now let's go into the script again. So now, well, we have two ways, I guess. One is to normalize the distance between 0 to 1. So if distance is 100 times, if distance is 100 times, we normalize it, and then we can control the speed to make it a static speed. But for now, I just want to not multiply, but to divide the distance by 100, and that will be the speed of the movement of the, so the bigger the distance is, the faster the ghost follows the player. So this basically means that like there will be a radius of whatever the maximum speed of the player is. There will be a radius where the ghost is moving as fast as the player. So it will always remain caught up, I guess. Well, anyway, does that make sense?
That makes 100% sense.
Okay, so let's do it then. Let's add. All you need to do is to use the current location of the player, and then you add the distance minus 100, and that should do it.
RB.
Actually, yeah. You can't do this var. So it has to be like self global transform origin.
Yeah, but wait. Okay, so var A.
No, let's call it var D or var C. Let's call it var C because it's confusing you.
You know what I'm saying? No, because if we're gonna.
Oh yeah, a plus distance minus. Yeah, you're right.
Yeah. See, like, what's the point of making those variables? We're just gonna keep retyping it.
Distance 100 divided by 100. Okay, great. So now you have to put it into this. So that equals that var. So instead of var, type in this equals this. And you can't do a equals a plus distance because that wouldn't update the origin. Does that make sense?
Yeah.
A is a copy of origin. A isn't the actual origin location.
Okay.
Okay, so let me see how does that fly. So that's almost correct. You need it to be a plus distance.
Oh, I see.
Or the other version is plus equals. That will also work. Okay, so now no, if you do that, then you delete this. You don't need A at that point.
Oh, because it's self. You know what? We'll keep it there.
Okay, but then
I'd rather have it written out. Hey, two equal signs. Is that good?
That's very bad. Okay, so save it, and then let's try it. So either we have a bug or it works as expected.
Ooh, cool. I mean, it floated a little bit. Whoa, look, it's going. That's so cool. That is cute.
Okay, so now I guess you can push the zero.
It follows my jump too.
Yeah, it's a true fairy. So what I would do is I would place it somewhere near the chest height. So just go into the graphics and move it up. Just move it up by a meter, by this box. Move it up to here.
This?
Well, maybe a little bit. Let's not have it hug the ground. Yeah, like that. Perfect.
Okay.
Okay, so delete this print and...
We did it. We made a fairy like in 20 minutes. This is good video content.
Yeah. So there is just one another thing I want to do.
Oh, it's still... Okay, so I've got two choices here. And I could do... because it's
I'm pretty sure you didn't save.
Oh, I see.
No, you never started the restarted it. So
I think I did. I thought I did.
I mean, I'm pretty sure it didn't save.
That could be a name. British. Yeah,
Yeah.
I did, dude. It's thinking.
Oh, why? What the? Why is it syncing?
I think it's going to the origin of the player. See, the funny thing is the true origin of the player is on his feet. The origin of the player is not on the body.
Yes, but it's the sprite that we are moving, and the CSG should be where it is, you know. Oh no,
it's thinking towards it.
You move the sprite, so move the sprite back.
Yeah, I got it. I know.
Move the CSG sphere, and that will work. I am not sure why that's
funny. Just funny. Okay.
I don't know why it's doing that, honestly.
It's okay. I mean, like I said. All right. Okay. There we go. Now it's a little hover.
Really strange, but okay.
That's so cool.
So one more thing. And that's that we don't want it to enter your head. So let's just stop moving if it's within 1 meter of the player. So a simple way will do that. So
stop.
Okay, so if something is less than 1, what are we checking? Give me an idea. Be a program and tell me.
We're checking the position of the.
No, we have a higher level number that gives us the distance.
Oh, not 1?
Yeah, actually it is greater than 1. No, it is about greater than 1. No, because it's in meters. I mean, it's the character is about 2 meters high, 2 points high. So, okay, what variable out of these are we using? And let's not use the. Okay, what? So we have a variable that represents the distance between the players. What variable is that?
Var B.
No.
Sorry, var distance.
Yeah, so it's except it's not var, it's just distance. And this is a vector, so dot length, I think, or dot size, something like that. We need to get a float of its. And that's a function. Then GTH. Okay, yeah. Say that, and you need a double column there, and then make line 14 inside of the if. So line 14 goes into the if, because we don't want to run line 14 if the ball is too close. And destroy the print at line 13. So kill it with fire, please. And either that's going to work or we'll have a bug. Yeah, let's try it.
Oh, it's kind of in the head. Oh, no, it's not.
Okay, so it seems that we are amazing developers. So yeah, keep away as far as you can from it. It's really
He's gonna be super happy about this. Wow, we could do things now with the if we added a collision and just have it ignore, we could have it with the traps and stuff now too.
Oh, sorry, what do you ignoring?
Well, you know what I mean. Like I could have the ball. Like I could have the ball if it gets in here, it could actually block the laser. I mean, not to overcomplicate things. I'm just saying.
You are seriously. You're serious.
You're saying worse than my student.
Yeah, like his ideas are same, yours are. This is the problem, like that we are running into, you know, with the arrow game. Like this, easy, you know.
Yeah, I know. That's why I want to try to simplify
all of the interactions.
Features.
That's a nightmare. You know, the systems. Just getting the basic system out and it not talking to anything else, that's simple. But the actual interactions between systems, that's a nightmare to accomplish.
I overcomplicated this. I really overcomplicated this. All right. Okay. Awesome. Let me save it all. Let me stop the recording there. I think we have a good video here too.